All right. First thing, fundamental theorem of algebra. What that basically means is without it, we wouldn't have algebra. And it actually takes you a long time to get to the fundamental theorem of algebra. You might think it's like if you add 2 to one side, you have to add 2 to the... No, that's not the fundamental theorem of algebra. That's just balancing. All right? It's every polynomial, meaning something that has a lot of terms to it. And it has to be an equation with degree greater than 0. So x to the first, for example. Has at least one in the set of complex numbers. Now, some of you were saying, but didn't you say some of them can have nice? Like it could be a root at 1, 2, and 3, right? Well, you can write 1 as a complex number. You write 1 as 1 plus 0i, right? Basically, any number can be written complex. And over there, we just had some. It'd be 1 plus 3i, 1 minus 3i, and the ones that we were just working on, right? You see how those are complex? Okay. So basically, what it says in layman's terms is what I've been telling you all along is if you got x to the 7th as your highest, you're going to have 7. They might not be nice. Okay, that's what it boils down to. Okay, and yeah, sometimes you're going to have to go find something like that. Okay, we're going to work towards that. Descartes' Rule of Signs. Anybody remember from Algebra 2? I know if you had me, I gave you his first name. I don't know if Mr. Evan does. Descartes' first name. It does begin with an R, but it's a fairly uncommon male name. Yes. Close. René. René Descartes. So it's Descartes' Rule of Signs. It is not Descartes. Okay, it's Descartes. It's French. All right, they just say whatever they want. All right. You can read this if you want, but there is a slight typo. Right here should be a negative and a negative. Make sure that yours has that in there. For those of you that actually like to read those things and try and figure out what they mean, because that's what you're going to have to do in college. All right. Here's what it means. It says the number of positive real zeros is the same as the number of sign changes, or less than the number of sign changes by an even number. Fairly straightforward if you've seen those before, which you have. I just tell you always to go down by 2 is what you were always taught by me. Okay? Until it makes no sense. So let's do a positive for this one. The first thing you need to know if you're going to do Descartes' Rule of Signs is it better be in descending order. Is that one in descending order? And actually, the way things are going today, I better ask you if that's the same example that you have. Okay, good. So what you have to do, basically what you're going to set up is that, the chart. Okay? The key is number. You're not telling me what the root is, you're telling me how many there could be. Now, x to the third, this particular one here is an odd function. Remember, that means one's going to be ending up, one's going to be ending down. You got that? So if one's going up, one's going down, it has to at least hit once. The x-axis, that's what we're looking for, how many times it can hit the x-axis. Well, all you have to do is go ahead, you start from the left, and I go to the right, and I put those little loops in. You agree there's a positive 1 really sitting right there? And you just go ahead like this and say, is that a sign change or not? It went from a positive 1 to a negative 6. Did the sign change? Yeah, and I just put a little y there for yes. From negative 6 to a positive 1. You see how you just kind of keep going that way? Did the sign change? It went from negative 6 to positive 1? Yes, it did. Okay. And then you just add those up. Well, how many are there? There's 2. Now, the reason that you go down by 2 until it makes no sense is because of these functions kind of look something like this. All right? So it could hit twice. Because x to the third, again, looks something like this, right? That's what x to the third looks like. Is it possible that that could hit the x-axis twice? Is it possible? It actually is. It could do this. Well, okay, actually hit it when you try and draw a picture, but do you agree that it's hitting the x-axis twice? Right? Is it possible, and it's in the positive, well, this is a bad example. Slow down. That's a better example. Do you agree those are both positive? Positive numbers, right? Maybe positive 1 and positive 4 or something like that. So it's possible for that to happen, correct? Is it possible for me to take that same graph, how many positive roots does that one have? Positive roots. None. Do you agree that is possible? Based on the shape of these graphs, if you go down by 2 until it makes no sense, it fills in the graph for you. Because how they go up and down, all over this, like a roller coaster. So is it possible to have 2 positive roots? Yeah. If you go down by 2, you get to 0. Is it possible to have 0 positive roots? Yeah, I just drew you the picture right there. How about -2? A -2 number of positive roots. You're saying how many? Does -2 make any sense at all? No, not if you're telling me how many. How many A's did you get? -2. What? What are you talking about? All right. Yeah, I don't know what the -2 A's means, but yeah. So now, that's how you do positives. All right, so you find out, you just do the sign changes, and then you write it down, and then you keep going down by 2. So obviously, if I started with 6, you'd go 6, 4, 2, 0. Right? That makes sense? That's how you would do it. So to do negatives, the one I had you change there is you have to substitute -x in. So let's just put -x in every place we see it. All right? Like that. Right? You notice I just went right there, put in -x, put in -x, and kept going. And then once you do that, you just got to kind of clean it up. So if I took a negative number to the 3rd power, is that going to end up positive or negative? Negative, right? So do you agree this is really just saying -x to the 3rd? Right? That's what it's saying. How about here? We got a -6 kind of hanging out front. Well, let's do this. If I take -x and take it to the 2nd power, because that's what order of operations tells you to do first, right? -x to the 2nd power, is that positive or negative? Just that part is positive, right? But once I take it times that -6, well, it's negative. +1, is there anything I got to do with that? No, it's a +1, right? So you would agree basically this is P of -x, which is what I told you to put for that -1. What it tells you on that other, well, up above, it says to basically do the same thing for P of -x. Count the sign changes, all right? And go down by an even number, okay? So if we have this, are there any questions how I got that? Let's count sign changes. Did the sign change from -1x to the 3rd to -6x squared? No. Did the sign change from there? It's -6x squared to a +1. Yes, it did. So how many total did I have? 1. 1 negative. So we know for a fact that there's going to be 1 negative root. Do I know if it's going to be nice or not? No, but I know there's one of them. Okay. So, everybody go with that? We know there's how many total? 3 roots total. Okay, so let's just look right here. It is possible that 2 of those roots are positive. It is guaranteed, basically, that one of the roots is negative. We don't know if it's nice or not, but we know it's negative. So if 2 are positive and 1's negative, how many are left over to be imaginary in this case? If there's only 3 total, haven't we already talked about all 3? So there are none left over to be imaginary. Okay. How about if there are 0 positive? Well, how many negative do we know we're going to get? Because does it make sense to go down by 2 here and get a -1 number of something? No. And so what am I going to put here? Do I just won't write anything? Because you can't go down by an odd number. How many negatives do I know I have? I have 1 of them. It's guaranteed that I have 1. Okay, it's right here. We know we have 1. So if you ever start a column with a 1, you can write 1 as many times as you want. And if you ever start a column with 0, you can write 0 as many times as you need. Okay? So if there are 0 positive, 1 negative, how many total were there again? 3. How many are left over? 2. Now, I am very much unaware as to whether those of you that had Algebra 2 next year were responsible for graphing possible ways that it happened. Did you have to graph them? Did you do little sketches? Oh, well, lucky those of you that had me, because you've done this before. I just showed you what x to the 3rd looks like, right? Something like that, right? What you have to do is for each one of these possibilities, show me how it could have possibly happened. Does your graph have to even remotely be accurate to the actual graph? No. But if you know x to the third looks something like this, it better look something like that. It better not look like this. All right? So let's try this one. So we'll say the graph for this one's right here. I need to have two positive roots. So here's what I do. I go to the positive, I put a dot there, there's one of them, and there's the other one. You agree that's two positive roots? And we need one negative, right? So should I also put the negative right here? Does that look like a good spot? No, that's a positive. Don't put it there. Where are you going to put it? Over on the left somewhere. That's negative. Just put something over there. Is it possible to take this little graph looking thing and have it fit onto those points? Yeah, you just go through that one. You say, oh, I'm just going to come down. And then maybe you feel like really going far down, and then you come back up. Okay, you doesn't have to exaggerate it like that, but does that meet the requirements of what that one row said? It said two positive, one negative, no imaginary. Yeah, because if there's three total, right? And I see all three of them. So they can't possibly be imaginary if I see them. How many positives should I do for the second one? None. How many negatives? One. Just pick a spot. Any ideas how I'm going to make that happen? How could that? What could that possibly look like? Yeah, I saw some of you kind of doing that. Yeah, you just kind of go up like this, and when it comes back down, it doesn't quite make it. There you go. That's it. So now you're saying, well, how do we see the two imaginary? Well, the thing is how many totals is it supposed to have? Three. How many do you see? One. You don't see the other two because they're imaginary. Okay, that's why you can't see them as dots on here. Okay, if we graphed on the imaginary axis, which would be tons of fun for me, probably not for you. We could see them, but we don't want to see them here because we're doing it on the coordinate plane. Okay. Any questions on that? There's a really good question on this one, too. Where's the x term? How come I didn't worry about it? Because what have we been replacing? If there's a term missing, we just put 0x in there, right? How come I'm not worrying about it with Descartes? I never even mentioned it, did I? 0 is neither positive or negative. So how could it count as a sign change if it's neither positive nor negative? So you don't have to worry about them. That's a great thing about Descartes' rule of signs. So is it possible to do when that's x to the fourth? Yes, there is. But how many total are there going to have then? You're going to have 4. Does it really change how you start the problem? No. What did we start with? Again, what did we do first? That was a long time ago. What did we do? Just make stuff up? Just count the sign change. But what was the first thing I told you to look for? Make sure it is in what? Descending order. How's this one? Is this one good? Yeah. So what do you think? Yes or no? That's a big no. No. Yep. No. So how many positives? Now remember, if you start a column with a 1, you can write it as many times as you want, but do I know how many times I need it yet? No. It is very possible to have one row in Descartes' Rule of Signs. That can happen. In fact, it's kind of nice when it happens because you know exactly what you're going to see. So now I have to do f of negative x because I have to find out and do sign changes of that. What it really means is take wherever you saw an x before and replace it with negative x. Some of you are going to get quicker at this particular step, but please take caution that you do it properly. And I'm going to run out of room. It's not a 91 at the end, it's just a 9 and the 1 is for the sign. How about negative x to the fourth? End up positive or negative? Yeah, say it. You're right. Be more confident about it, though. Positive. How about that 5? We got negative x to the third. What's the end result of all of that? Once you're done with all of it, it's going to be Because it's negative x to the third, which ends up negative, times a positive 5 is negative. And my negative can't be seen very well there, but there it is. Negative x to the second ends up positive, times a positive is positive. And then we have a negative times a negative is positive, minus 9. Yep. Yep. No. Yep. Well, this hasn't happened yet. We're going to start a column with which number? 3. All right. Let me get that out of there. It's kind of bothering me. So now, 3 is a possibility. But if 3 is a possibility, remember, you can always go down by an even number until it makes no sense. So does 1 make sense? It's 3 minus 2. You could have 1 negative. It makes sense. How about negative 1? Number of something. Yeah, that doesn't make any sense. Okay. So let's start this here. How many total again? 4. So if one of them is positive, 3 of them are negative, how many are left over to be imaginary in that case? If there's 4 total, 1, 3, 0. Now the real question is, what do I put kind of over here in this positive column here? What can I put right here? Yeah, it's a 1. You can write it as many times as you need to. And I need to kind of finish off this row. All right? So do you agree? 1 positive, 1 negative. How many are left over? 2. Because you agree both rows now total 4. Because x to the 4th. Okay. So, does anybody either remember from Algebra 2 or from other classes what x to the 4th looks like in general? It can be a parabola, but it can also be basically a W. You had one on your worksheet, x to the 4th, I believe. Can look like a W. It can be a parabola. Basically, it just takes out the extra loop. But it can also be that. It can be lopsided W2. They don't have to be, you know, symmetric. So, let's see what you can do about this one. You need to give me 1 positive and 3 negative. So 1 positive and 1, 2, 3 negative. Do you think you can make a W type shape with that? Yeah, it doesn't go through, right? There it is. That's what it could look like. How about 1 positive, 1 negative? Lots of ways of doing this one. I told you it could be a parabola if you wanted it to be, right? But you can actually fit a W in here if you wanted to. Anybody kind of know how to fit a W kind of shape in there? Not what I was thinking, but that works. What she's saying is that you just kind of go like that. That works, right? Is that the only way? No. You know, you could have done something like, right? Okay. Does that work? Okay. Yeah, not what I was thinking, but this that's perfectly fine. Okay. So I think that's it, right? So perhaps what you might want to do on the back. Y equals x squared in general looks like parabola, right? Y equals x to the third in general. Something like that, right? X to the fourth in general. So anybody want to take a wild guess? Even, ending in the same direction. Odd, ending in opposite direction. So basically x to the fifth is x to the third with another little possible, doesn't have to, but another possible loop. So this could do x to the fifth. This gives it a chance for another change of direction. Because let's see. 1, 2, 3, 4, 5. Do you think you could probably handle x to the sixth at this point then? It's basically x to the fourth with another change of direction involved. Okay? 1, 2, 3, 4, 5, 6. Again, does that have to happen though? No. Okay, but that's what it could look like. I think you get the idea. X to the seventh is just this one with another change of direction. You get the idea. Okay. Questions? All right. You don't want that. You want this? Okay. You can kind of disregard some of these directions. You can probably tell it's not my handwriting. It's a little bit too neat for me.